Question 7, for which values of k does the following system of equation have an infinite number of solutions? Okay, first, recall that a system of linear equations has infinitely many solutions if, first of all, it must be consistent. If it is consistent, meaning that in the row reduced echelon form of the augmented matrix of that system, we don't have 0 equal to non-zero. And the row reduced echelon form of the augmented matrix has a column without leading one, has at least one column without leading one. Okay, so we go up there, then try to generate this case. So 1, 3, 0, k2 minus 1, 7, k minus 1. The augmented matrix is given like this. There are k in it. And the first thing you have to ask yourself is that, is this an a row reduced echelon form? Well, you look at there, the first leading one is in the right place. The second entry that we see here is this guy. So the point is that, can I make that one next leading one? Well, you can make such an entry always next leading one if that entry is non-zero. So there are two cases. If k2 minus 1 is not 0, then we can turn it to next leading one. How? Well, just by multiply the whole row 2 by 1 over k squared minus 1, by 1 over k2 minus 1 times r2. Okay? And then if you do that, in that case, then both columns on the left-hand side, on the coefficient side, are going to have leading one. So then we, all the columns are going to have, all the columns of the left-hand side of the separating line are going to have a leading one. And if all the columns have a leading one and the system is constant, then we will have unique solution. And right away you say, okay, no, that's not what I'm interested in. I'm not looking for a unique solution. I'm looking for infinitely many solutions. Yes. So we have to exclude that. So then the next case is that k squared minus 1 must be 0. If k squared minus 1 is equal to 0, first of all, there will be two consequences for this. K is going to be either 1 or k is going to be negative. Yes. And then, well, our matrix, our augmented matrix, is going to turn to this case. So k squared minus 1 is 0. But the right-hand side, I have k minus 1. This will be also 0. If k is negative 1, our matrix is going to be like this, 0, 0 here. If you plug in -1 for k on the last coefficient, the constant side, it will give you -2. Okay. And then you look at this guy and see that, oh, look, this guy is inconsistent. And inconsistent means that, well, it doesn't have any solution, let it alone to be infinite, to have infinitely many solutions. This guy cannot be our case. So we already excluded that part. We already excluded this part. Now the only remaining part is when k is equal to 1. So let me just continue from here. When then k is equal to -1, you see that this is row reduced echelon form, and the first column has a leading one, but the second one doesn't have a leading one. It is a consistent system, and as a result, will have infinitely many solutions. So as you see, there's only one case that will give us infinitely many solutions, and that is when k is equal to 1.